In this lesson, you'll learn about the polygon angle sum theorems. The objective is to find the sum of the measures of the interior angles and the exterior angles of a polygon. The first theorem is the polygon angle sum theorem, which says the sum of the measures of the interior angles of an n-gon is n minus 2 times 180. Now, what's an n-gon? An n-gon is just a term used to refer to a polygon with n number of sides, however many number of sides n is. The reason that it's multiplied times 180 is because if you take, let's look at a few different polygons. Let's look at a four-sided polygon, which is a quadrilateral. And if I draw a diagonal, it's going to divide it into two triangles. If I have a pentagon, and from one vertex I can draw two diagonals, and that will divide that pentagon into three triangles. And just keep going up. If I have a hexagon, hexagon has 6 sides, and from one vertex, if I draw the number of diagonals from that one vertex, then I have formed 4 triangles. So the idea behind this is that by dividing a polygon with n sides into n minus 2 triangles, you can show that the sum of the interior angles measures of any polygon is going to be a multiple of 180, because there's 180 degrees in each triangle. So you're just multiplying it by the number of triangles that can be drawn inside the polygon. Here we have a few definitions that follow that we've already used in previous lessons, but just as a review. An equilateral polygon is a polygon with all sides congruent. So equilateral. And then an equiangular polygon is a polygon where all angles are congruent. And then if we have a polygon that's both equilateral and equiangular, it is called a regular polygon. There's a corollary to the polygon angle sum theorem that says that the measure of each interior angle of a regular n-gon is going to be the sum of the measures of the interior angles, which is n minus 2 times 180, and then divide that by n, which is the number of sides, and which is also the number of angles. So if you only want to find the measure of one interior angle of a regular n-gon, you take the sum of the total of the interior angles and divide it by the number of angles. The next theorem is the polygon exterior angle theorem, and it indicates that the sum of the measures of the exterior angles of a polygon, one at each vertex, is always going to be 360. So for this pentagon below, we have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 is going to be a total of 360. And if we only want one of those, if this is a regular polygon and we only want the measure of one of these, the measure of angle 1 is going to be 360 divided by the number of sides, which is going to be 72 degrees. for the measure of one of the exterior angles of this regular pentagon. So let's look at some problems. Problem 1, you're finding the sum of interior angles, and it asks what is the sum of the angle measures of a tengon. So what's a tengon? It's a polygon with 10 sides. They could have also called it a decagon, but here they called it an tengon. So we're going to take the formula for the sum of the measures of the interior angles, which is n minus 2 times 180, and just substitute in the number of sides, which is 10 minus 2 times 180. That's 8 times 180, and that equals 1,440 degrees. In problem 2, you're finding an interior angle measure. Here Marcy creates a floor tile pattern using squares, regular hexagons, and regular dodecagons. If you remember, a dodecagon is a 12-sided polygon. So what is the measure of each angle in one regular dodecagon? So we just want the measure of one angle. So we're going to take the sum of the measures of the angles inside the dodecagon and then divide it by the number of angles, which is 12. So let's take our formula. N minus 2 times 180 is the sum of the measures of the interior angle, but we only want one of them, so we're going to divide it by the number of angles. So we have 12 minus 2 times 180 divided by 12. And if you plug that into your calculator, you would get the measure of one angle is 150 degrees. In problem 3, we're finding an interior angle measure, and it asks what is the measure of angle D in quadrilateral ABCD. So what is the sum of the measures of the interior angles of a quadrilateral? In any quadrilateral, you've got n minus 2 times 180, and it's four-sided figure, so 4 minus 2 times 180 is 2 times 180. So the sum of the measures of the interior angles of a quadrilateral is 360. So here we have 3 of the measures are known. Measure of angle A is 98, B is 91, C is 112, and we want the measure of angle D, and all of those have to add together to be 360. So if you solve this and add the 98 plus the 91 plus the 112 together, and then subtract that from 360, then the measure of angle D is going to be 59 degrees when you solve for the measure of angle D. In problem 4, you're finding an exterior angle measure, and it asks what is the measure of an exterior angle of a regular hexagon. So in a regular hexagon, it has 6 sides. And we know from the Polygon exterior angle sum theorem that the sum of the measures of the exterior angles of the polygon is going to be 360. So we need to find a measure of angle 1, which is one of those exterior angles. The sum of all of them is 360, and we're going to divide it by 6, because that's the number of exterior angles that there are. And so that's going to be 60 degrees.